Hi folks, today we're going to do a load test on this new 3600 watt rated generator. The reason for the test is basically to see if it meets the manufacturer's claimed rating. Because of the noise of the generator and also a cooling fan on our load bank, which we'll discuss here in a minute, we're going to provide an audio narrative of the process and then insert clips into that of the actual test that has already been completed. This generator is rated for 128 volt output and is equipped with an AVR, automatic voltage regulator. It has a standard two outlet, a duplex outlet here. It also has a twist lock and a third outlet, 30R, I believe it's a 30 amp rated outlet for going into an RV or something like that. At the present time, I've got a twist lock jury rigged in here. The cable coming out is a number 10 cable going to my load bank, which we'll be looking at in a few minutes. And also there is an extension cord plugged into this receptacle that's going to a kilowatt unit, which will give us just an indication of the frequency that this unit is running at. This generator came with an oil container. I believe this is 0.63 quarts, just enough to fill the crankcase. It came with a spark plug wrench, and it came with a 10 by 13 open inch wrench, and also with an oil funnel, if you will. Although this one is a little unique in that it is actually threaded. Once the filter plug is removed, it'll actually screw into the opening and reduce leakage. It's really pretty cute. I've never seen it done before. The generator fuel tank is equipped with a fuel gauge to indicate fuel level. It's a nice little feature for a small unit like this. This is my homemade load bank. It's, as you can tell, it's been assembled from salvage material that came out of my shop at my son's shop. The device contains 9 heating elements which are suspended in this tube, which is about a foot square, give or take. And each of these heating elements is rated for just under 5 kW when operated at 240 volts. Of course, today we'll be operating only 120 volts on these elements. Each heating element has a resistance of approximately 11.5 ohms. Air is forced through the tube to cool the heating elements using this blower. This is rated at about 1,000 cubic feet per minute and is powered from a separate 120 volt circuit. In other words, I mean that a wall circuit is supplying the power to drive the motor. It doesn't come from, it is not getting its power from the generator that's feeding the load bank. The power into the load bank, this is just a piece of number 10 Romex cable that's coming in here, comes into this 100 amp 2-pole circuit breaker, and this acts as a disconnect for the entire device. The unit is equipped with these 8 switches, and by positioning these switches, I can select a resistance or an amount of load that's going into the generator. I reference this a table that I have printed out here, and basically it gives me The first column here gives me the expected resistance for where the switches are set, and also the load in watts, if it's 120 volts it's going into the unit, as is the case today, or if what the load would be if 240 volts were being sent into the same terminal. The monitoring equipment includes this little electronic load monitor, which gives a readout of voltage. It gives current, kilowatts, kilowatt hours consumed, and also indicates frequency. However, the frequency on this little device seems to be just a indication of whether you're connected to a 50 hertz system or a 60 hertz system, and it doesn't really give you a reading of the frequency. So for that purpose, I brought in this kilowatt unit that is commonly available. It's a very nice unit, and by punching the buttons up on this, I can see what frequency the generator is producing. So as we move forward, I usually will indicate, read the meter, probably write down what it's doing, then move to a new load, apply the load, and so forth as we make our way through. And you will notice, actually, as I do this, that I am applying the load and then removing the load, setting my switches. My switches have turned out to be a little too light for the load, so I don't switch them under load. I go ahead and set them up and then reapply the load. This of course, is just the first generation of load bank system. I'm going to have to try to make some improvements to make that a little easier to use. What does a generator have to do to meet an electrical load? It must provide an output voltage very nearly 120 volts if it's a 120 volt generator, or 240 if it's a 240 volt generator. And the frequency output must be very near 60 cycles. Now my definition of the generator no longer being able to meet the requirements of the load is if, let's say, the voltage is not within 5 volts, or say 115 volts, and if the frequency of the generator, or I should say, if the frequency of the generator is more than 3 cycles away from 60 hertz. So it's not good enough. It's not good enough for me to take my little chart here, set the resistance for a load that I think is going to be about 3,100 watts, put it on my generator and have it sitting there still running, but it's slowed down. The frequency is maybe 50, 55 hertz. The voltage is down to 105, 110. That's no longer meeting the definition of what's required for an electrical load. And that's where I determine as being a cutoff for the generator as far as its ability to meet electrical loads. The procedure that you'll see will be, I'll apply a load with all the switches in the off position. The load will probably be about 139, 140 watts. I'll record that, then I'll reset these switches. After I shut the power back off, I'll reset the switches, change probably to around 600 watts, turn the power back on. I'll read the meters, record that just with a pencil. And finally, we'll be getting up into the range of 3,000 plus watts on up toward 3,600 watts, and we'll see how the generator does. During this test, I had no automatic recording device, so I needed to take notes by hand as to what was happening as the loads were changing. And what you see before you now is my worksheet. Sorry for the sloppy notes, but hey, it's just the way it is. The first column here represents watts, and then the next one is the volts, and finally HZ stands for hertz, or the frequency in cycles per second. The first load that was applied was produced a output wattage of 152.5 watts, and basically that's a situation where all 9 of the heating elements are hooked up in series. Then as I flipped the toggle switches that you saw during these heating elements were hooked up in parallel or series to change the loading on the generator. So basically what was happening here is I was switching, and the next one I was actually switched it so the load went up to 686, and as you see the voltage is 122, very, very commendable, 60.5 hertz. Everything was looking very good, and the load keeps increasing till we get to this point at 3,120 watts. Still the voltage looks good. Frequency is very reasonable, 59.5 hertz. And then the next step, I was attempting to increase the load, but as you see, it didn't change. It actually went down from the previous line. In the next 3 lines, I was changing switch settings, but I wasn't getting any increased load. And then I began to realize that as I recorded the voltage was staying up, the frequency was staying up. Basically, I had a failure in my load bank, and at that point, I realized couldn't go forward. We went ahead and shut the generator down, and I drew a line across there and went back and made some repairs. Those repairs included replacing one of the toggle switches and tightening up some of the wires and so forth. When we started the testing again, we started at the same setting. It was back up here. This time I got 3,100 watts. Again, the voltage looked good. Frequency was quite reasonable. And then the next line, I'd increased the load some additional amount, and instead of increasing the load, it went down, similar to what happened up above. However, you'll notice that the voltage dropped to 110 and the frequency dropped to 46.6. The generator was going down on its knees. We had reached all it could do, and so I reset the switches back to the setting that we saw on line 1. This time I got a reading of 3130. I can't explain why the numbers are a little bit different. Could be, just the errors in the metering equipment, or maybe the heating elements changed a little bit. Seems like each time you reset to the same position, you don't necessarily get identical numbers again. And again, I had 121 volts, and the frequency was right at 59.3, pretty good. And at this time, I was scratching my head trying to decide, what do I want to do next. Apparently, I took the power off, and then I decided to turn the power back on. And this time, the voltage measurement was not a reading necessarily off of the power monitor, but it was obtained using a Ames multimeter. Again, the frequency was looking good, and this time I shut the generator down and then measured the DC resistance at the terminals to the load bank, and that came out to be 4.5. At this point, by Ohm's law, V squared over R represents the power of an operating system like this. So we had 121 volts times 121, which is V squared, divided by 4.5 ohms, and that predicted a 3,253 watt load. So basically this was just kind of a check to see if our 3,000, 3,100 watts was reasonable. It predicted a little bit higher, obviously, 253 watts or maybe 153 watts higher than the power meter. But also we know that as soon as I took the power off of the unit, the resistors would cool off slightly in the heating elements, and it may have shifted the ohms. And also when I get down to, say below 10 ohms, my ohm meter, I can get varied results sometimes. It's very hard to get good accurate readings, but I have some faith that around 3,000, 3,100 is probably about the best we were doing here. Also, I have the kilowatt unit. I had checked it up to its limits and found that the wattage recorded by the power monitor and the wattage as recorded by the kilowatt unit were very similar. However, the kilowatt unit is limited to 1,800 watts. So since we were getting up in the 3,000 watt range, I couldn't use that as a backup instrument to the main power monitoring unit. Okay. At this point, I decided to go for broke. And I went ahead and put the maximum amount or the minimum amount of resistance, which equates to the maximum amount of electrical load that this load bank could put on a 120 volt system. And I would expect, well, according to my little table, to if everything were ideal, to put, maybe I would have seen as much as 3,700 watts, give or take. This is number I'm pointing to here is just a theoretical number, but it depends on exactly what the voltage is and the temperature, the heating elements, and everything else. But what happened was actually when I put the maximum or minimum resistance on here, instead of increasing the load, it went on down to 2440, and the voltage fell to 93. And the frequency was down to 46.5. So the unit stayed online. By that I mean the engine kept on running, but it was really struggling and knocking along, and it was way past its ability to carry loads. So again, 3,100 seems to be about the maximum load that it can carry dependably. It's hard for me, to, again, guarantee the accuracy of this rather crude process that I've used, but I don't think it's way off. And I had some other reasons for thinking that perhaps this generator or some of these foreign-made generators were not meeting their manufacturer's claims. And in one of those, I'd like to mention Mr. James Condon, who regularly produces YouTube videos on generator repair and maintenance. And he did a test where he loaded a Predator generator, 3,200 watt rated generator, and it has a 212 cc engine, which is the same displacement as the engine that's supposedly on this Westinghouse. And he had some issues with loading this unit. And if you should find this interesting, in the comments below the video, I will try to leave an address if you want to take a look at his videos. I think you may find them quite interesting. I also had, prior to purchasing this Westinghouse, I bought a Sportsman 1,400 watt generator, and I did a report on this in a video, prior video, and I found that this particular generator has got about, I believe it's a 94 cc. It's always a little smaller generator, but it also had some difficulty meeting the supposed 1400 watt rating that the manufacturer claimed. So I'll leave an address for that video on the comments below if you want to take a look at that. I guess the situation is misleading ratings of the generator manufacturers. Is this an endemic problem that's for the portable generators throughout, or is it just perhaps the foreign-made generators? I'd certainly be interested in what you viewers have seen happen, or what experience you've had with these generator products. Anyway, I thank you all for watching. Wish you the best.